I'm Kara Lawson.
Hi, my name is Luke Waltz.
I'm Guoliang Wang.
My name's Alex Lindsay.
I'm Vinayak Shedekar. I'm an assistant professor of agricultural water management.
I'm an assistant professor in agriculture communication.
I'm an associate professor in the Department of Horticulture and Crop Science.
I'm a second-year PhD student.
I'm a professor in the Department of Plant Pathology at Ohio State University.
It is really hard to believe that it's the halfway point for my AgTech project already. It was recently piloted to make sure it was ready to go out to the 2,000 Americans who will tell us a little bit about their views of climate change.
We've really got a full data set at this point. Harvest is just happening with soybeans and corn. We've had a busy summer collecting data with drones, with time-lapse cameras, with smartphones, and then with a lot of soil and climate sensing that we installed at the 3 locations around Ohio.
Our project is working very well. We have finished 2 field experiments and 1 greenhouse experiment.
We're really excited about some of the results that are coming from our cold water exposure component to the project. And we're in the middle of harvest season right now, so we're getting our seed samples and getting those ramped up for our in-lab disease assays.
We're at the halfway point, which means the growing season is over. So which means we're at a stage where we're looking at the data that we have collected and just looking at the first preliminary results, it is looking very exciting for us.
The test of the survey actually happened in multiple phases. In the first phase, we tested the survey with about 80 people to help determine essentially if the survey was working how we hoped it would work. And once I got the data, I did some statistics to make sure from a statistical perspective that it was sound.
So we've seen some early results with some of our time-lapse imagery where we calculated the uniformity of emergence of corn and soybeans. We've also seen a correlation between our soil volumetric water sensing and matrix potential relative to the precipitation across the 3 sites.
We have 2 research sites that we have implemented this project at. Essentially, we're monitoring these 2 sites for water budget components and crop physiological responses. What we noticed as soon as we started monitoring, we are able to see that the water table is retained in these fields for a longer time. We have preliminary results that indicate that the crops are responding slightly differently between the zone that is under a controlled drainage system versus a zone that is under a free draining system.
We finished the experiment with David Francis in Worcester. So we have started the experiment with Chris Taylor in greenhouses and hydroponic conditions. So we are going to finish this experiment in the next 3 or 4 months.
With this work, we're really going to start to understand how early planting affects disease impacts, particularly for certain pathogens. But we'll be able to start to look at the nuance a little bit more and better understand why that infection is happening to better prevent it from occurring in the future and make our production systems more efficient.
In the second half of the project, we'll have the data to create an interactive map to just show exactly what the perceptions are throughout the United States. We'll also be working on an audience segmentation report, which is essentially going to be an analysis of how different groups view the issue of climate risk.
The data set is complete, and then we're starting to really start on some of those use cases, which is around yield estimation, soil moisture, and growth stages. So really the remainder of the project will be really trying to build those algorithms, tune them, figure out which hyperparameters work best in the model, so that we can prove that we can estimate those things with some accuracy that would be valuable for a farmer.
We're going to be getting more into analysis on our harvested seed samples. We'll have a little bit more information about diseases and how that temperature, stress affects infection. We're also teaching a class that focuses on seed quality, so that's a unique opportunity for our students here at the university.
Really what our next phase is going to be is to start looking deeper into the database and then start talking to the producers about their experience with these technologies. And then we hope to synthesize the results based on the data that we have collected.
The AgTech Innovation Hub funding from Nationwide has meant everything to this project.
The best part of this was the ease of securing funding and the timing of the funding. It was very fast track.
We're using this fund to hire a postdoc, and so we can carry out all the experiment in the greenhouse, in the field, so we can test effectiveness of the products.
The funding from Nationwide really helped us really execute this project because it allowed for the time and the buying of the equipment, the soil and climate sensing, the unmanned aerial vehicle that we use to collect all our imagery. If you don't have great data, the best machine learning algorithms in the world really can't do much.
Without the funding from the nationwide AgTech Innovation Hub, this work wouldn't be possible because we wouldn't be able to look at these questions and address these producer-relevant issues, especially as planting dates become earlier and harvest season becomes more variable.
The opportunity to conduct a national survey wouldn't have been possible without our partners at Nationwide, and I so appreciate that. It's a huge undertaking, and it's not really possible without that kind of support.